just like the end behavior of quadratic functions was easily determined by the leading coefficient, right? If you had maybe, as a simple example, minus x squared, you knew it was going to be concave down. So as we move to the left infinitely, I move towards minus infinity, and as I move to the right infinitely, I move towards minus infinity. It's the same thing with polynomials. So the end behavior of a polynomial is going to be entirely dependent upon the leading coefficient. So identify the term with the most x's, so the highest power of x's, and then the coefficient in front of it is going to determine our end behavior. So for example, this function f of x, 2x cubed minus 7x squared plus 3. It's an x cubed function, so it's going to look something kind of like this, or maybe it looks like this. But because of that 2 right there, the leading coefficient in front of the highest power x, which is 3, because this is x cubed, that leading coefficient right there is a 2, meaning that it's a positive. So our end behavior is going to look something like this, something like the positive x cubed function. Again, it might do some weird things around here, but our end behavior are these two arrows. Right? We don't know what happens close to the origin. Let's work on h of x. It is, again, another cubic. The highest degree is 3, but this time the leading coefficient is a negative. It's negative 1/2. So it's going to have that same cubic behavior, except it's going to look like minus x cubed. So our end behavior is going to look something like this. The end behavior for s of x, this is a degree 6 polynomial with a positive leading coefficient. So it is going to have end behavior that approaches positive infinity as you move away from the origin. Right, because that even power, it's kind of like x squared or x to the 4th. It's now x to the 6th, and it's concave up. U of x here is a degree 4 polynomial, so we're either going to be both up or both down, and that negative 0.3 in front of the x to the 4th means that we go down. Again, who knows what happens here close to the origin, but that's our end behavior. I approach minus infinity from both directions. W of x is minus x squared. That's an even degree polynomial with a negative coefficient. So in fact, it's the same thing as u of x. It was an even degree polynomial with a negative coefficient. So we have the same end behavior. And finally, p of x is a 5th degree polynomial. That's the highest number of x's that I have, with a leading coefficient of 1. So it is going to look like this for its end behavior. It's going to approach positive infinity on the right-hand side and approach minus infinity on the left. Right? It kind of looks like x to the 5th.